In this video, we are going to learn how to identify association between two quantitative variables. First, we should look at the scatter plot. Scatter plot is a graphic display for two quantitative variables. Horizontal x-axis is for explanatory variables. Vertical y-axis is for response variable. How do the values on the response variable change as the value on the explanatory variable change? There is a positive association if as x increases, y increases. There is a negative association if as x increases, y decreases. There is no association if as x increases, y does not tend to increase or decrease. Next concept we need to learn is correlation. If data points follow a roughly straight line, the variables are said to have an approximately linear relationship. Correlation summarizes the strengths and the direction of the linear association between two quantitative variables. Correlation is denoted by R. Correlation values will fall between -1 and +1. If correlation is positive, then there is a positive association. If correlation is negative, then there is a negative association. The closer association is to positive or -1, the closer the data falls to a straight line and the stronger the association. The closer association is to 0, the weaker the linear association is. Here is an example about strong, weak, positive or negative correlation. In this example, we are going to learn association between two quantitative variables. For 100 cars sold on the lot of a used car dealership, would you expect a positive association, negative association, or no association between each of the following pairs of variables? Explain why. So you want to ask yourself, as the first variable increases, do you expect the second variable to decrease? If so, there is a negative association between two variables. If you expect second variable increase, then there is a positive association. If you expect second variable has no clear trend, then there is a no association between two variables. Question A. The age of the car and the number of miles on the odometer. Because as age of car increases, number of miles increases, so there is a positive association between the age of car and the age of miles on the odometer. Question B. The age of car and the resale value. As the age of car increases, the resale value decreases, so there is a negative association between the age of car and the resale value. Here is StatCrunch commands you need to use for your homework 4. Example 5. Use the following data to determine if there is a relationship between total offense and the number of points scored by USC, or total offense and the number of points by USC. Use the following scatter plots to determine if there is a relationship between these variables. There appears to be a positive relationship between the total offense and the total net points scored. From this plot, we can see there appears to be a negative relationship between the total offense and the number of pounds. Question B. Use the following StatQuant outputs to obtain the correlation between these variables. The correlation coefficient R is from here. Since the correlation coefficient is close to 1, we say there is a fairly strong positive linear relationship. It is positive relationship because the correlation coefficient is positive. In other words, as total offense increases, the number of points scored tends to increase. From the second output, we can see the correlation coefficient is negative 0.794. We say there is a moderate strong negative linear relationship. It is negative linear relationship because the correlation coefficient is negative. In other words, as the total offense increases, the number of pounds tends to decrease.